we are having here. This will be opposite hypotenuse. Sine 30 opposite. Okay, let's call this one PT. PT opposite over hypotenuse T2. Okay, and we can now come and say PT is equal to T2 sine 30 degree. But remember that our T1, okay, our T1, if we call this one PT, which is our horizontal, so our PT equal to T1. Why? This is a horizontal, this is a horizontal. If you call this one PT, which is horizontal, should be automatically equal to T1, which is another horizontal. And if PT is equal to T1, and we say PT is this, then we can say automatically T1 is equal to T2 sine 30 degree. You can see that. T1 is equal to this. That's for horizontal. What about vertical components? For vertical components. Vertical components? What are the vertical components? Vertical components. This is for horizontal, we consider this, we consider this. For vertical, this is the weight acting downward or with masses 10 kg. Then we are going to resolve this angle also in vertical. Let's call this one W. W will be equal to, we are going to have T2 cos 30. How come? In this case, the first time we resolve it for vertical, which is sine. When you are resolving for horizontal, we have cos. T2 cos 30. Okay? And the weight is, we are given, let's say for weight is equal to mg, which is mass 10 times 10, which is 10 times 10 is what? 100. 100 Newton. Rather, this is Newton. So we can equate 100 to this. 100 will now be equal to T2 cos 30 degree. 100 is equal to T2 cos 30 degree. You can see that? T2. So let's make T2 instead of the formula. T2 will be equal to 100 divided by cos 30 degree. Substitute T2. Let's call this one equation 1. Let's call this one equation 2. We are going to say substitute T2 into equation 1. And what is equation 1? T1 is equal to T2 sine 30 degree, which is equal to, and you know the whole of T2 has a function, 100 over cos 30. So instead of having T2, we are going to have 100 over cos 30. 100 divided by cos 30 degree times sine 30 degree. If you look at this very well, you can write this very well as a 100 times sine 30 degree divided by cos 30 degree. Put it at the base of each other. You remember from trigonometry that tan theta is equal to sine theta over cos theta. Tan theta is equal to sine theta over cos theta. Let's say tan 30 will be equal to sine 30 over cos 30. Which means we can say T1 will now be equal to, this one is just to recall that, okay? So from T1 now, because this is T1, will now be equal to 100 times tan 30. Instead of having sine 30 over cos 30 or sine theta over cos theta, we give you what? Tan theta, which is equal to 100 times tan 30. And we can get that one from our trigonometrical ratio, but not to waste our time, we can quickly go and check what will be the value of tan 30. And that is 0.5095. And if we try to multiply that with 100, we are going to have 50.95. 50.95 Newton. 50.95 Newton. And that is the value of T1, the tensional force that we are going to derive or get from this rope. And that's what we are told to get. If we are also told to find T2, we can also get that. Once you are getting T1, just substitute into equation 2. You get the value of what? T2. And that is the simple solution to question number 6. Question number 7. The question says two horizontal forces, 10 Newton and 8 Newton. You can see this is horizontal forces, 8 Newton and 10 Newton. And another force F inclined at 30 degrees to the vertical. 30 degrees to the vertical. You can see the diagram shown in the diagram above. And then the diagram shown, keep the body P. If you have to keep the body P in the equilibrium, what will be the weight of the body? If you have to keep this body P, this is the body in equilibrium, what will be the weight of the body? We are still following the same procedure we used to calculate this. We are going to resolve this question into both vertical and horizontal components again. The horizontal component, let's look at the diagram. This is horizontal. Then we also have an angle to the horizontal. This is horizontal. An angle will be to the horizontal. Normally, if you look at this is right angle to angle. This is right angle what? To angle. All together to be what? 90. So the one to the vertical is 30. Then the one to the horizontal should be what? 60 degrees. Okay? To resolve it, to consider it, to resolve it, we are resolving the horizontal components. Then we are going to have F cos 60 degrees. F cos 60 degrees will be equal to, look at the two forces in the horizontal. They are in different direction. And once they are in a different direction, we are going to subtract the two forces from each other. This is going to give us 10 minus 8. Can you see that? F cos 60 degrees will now be equal to 2. F will be equal to 2 divided by cos 60 degrees. You remember, recall that cos 60 degrees is equal to half. Okay? Our force F will now be equal to 2 divided by half, which is equal to 2 divided by half, which is equal to 2 times 1 over 1. Because if when you want to change this sign, we want to move this one up, this one come down, this sign will change to multiplication. Okay, so this one will go up, this one will come down. So what I'm going to have for the value of force will be 2 times 2, 4 Newton. It is not force we are looking for. We are looking for the weight of the body. But we need to get the force first. And we get the force by the time we resolve the horizontal what? Component. Let's resolve the vertical component. We solve the vertical components. Let's look at the diagram again. For vertical components, the weight acting downward in a vertical direction. Then we have the force component to the vertical inclined at angle 30 degrees to the vertical. So what you are going to do now is you are going to take F sine 30 degrees will be equal to the weight, and we have gotten the value of F. For F, we have 4. Put 4 sine 30 degrees, which will be 4 sine 30 degrees is 0.453. Let's multiply that by 4. 1.815 Newton. Approximately, you can have 1.82 Newton. And that's the simple solution to question number 7. We are going to consider another new topic, and that is simple machine. Under this topic, the candidate should be able to identify different types of simple machine. At the same time, being able to solve